that water pump.
I am going to have you fill.
Okay.
I am
So
going
you're
to
gonna do
do
that.
I got it.
Be taxation. All right.
Flag Safety Supply, Wisconsin company.
As soon as I go, I go back up, right?
Yeah, well, no.
Too sexy for my coffee. Sexy for And there's a chance you're deaf, people pay attention.
Is this what? What did you say?
There's a chance you're deaf, people pay attention.
Wait, take night.
Oh,
I was just standing behind
Jim, I
Jake.
don't trace a little black steel.
Oh. No.
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 No. Yes?
Shower.
That was an average one. They get better.
Why was it smoking so much ahead?
It's a little, just some of the liquid nitrogen was still coming out of the top. But it doesn't matter because the rate, it's all about the rate of expansion.
Okay.
Yes?
The rate.
Lee, here's another cap, boss. Oh, you had one. I didn't see that. Okay, my bad. Here, okay. Whoa! I got them. Hooray!
I think that works better.
1, 2, 3. Thanks. That was okay. All right, we're gonna need another Diet Pepsi attack. I just used one of the ones for the show. So. Well, I call that a attack.
That worked.
The other one will help watch this away. There's 3 more packs. Get another one.
Okay, we're gonna do this back.
Well, we might as well take the hose out of there then and do something and put some kind of chamber there then, if that's the way, if it doesn't do any good. Oh, I can smell it. Wait a second.
Definitely fills up.
Okay, well, try it. Shoot it. I want to see what happens. Okay, do another one if you can. So we got 2 decent ones out of it. We'll try one. There's the 3rd one. Good. All right. So all we need to do is find the chamber for this, and we're good. Okay, so the temperature of the water in that bath is about 69 C. Now we will begin the test. Thermochromic put in to the warm water. And in just a few seconds, you can clearly see that the diamond thermochromic paint is already changed color because it is warmer and got warmer more quickly than the other 2 substances. So this is a conductivity test with a thermochromic paint top It changes color when the paint gets to about 30°C. Now let's put it in a little longer. So you notice I'm not putting the entire thing in, just the bottom. So the bottom soaks up the heat that is moving from one end of the substance to the other. And over time, you will see now that the metal is beginning to fade as well. And you can see now that the metal is starting to fade. Because it now is also at the proper temperature for the thermochromic paint to change. You may have also noticed that at this point the plastic has still not changed color. So now we'll set it in a little longer. Oops. Yes, that's great. Oops is very good for these sorts of videos. It's my own zeal. There is the slightest amount of fading has started now in the plastic layer, but of course the transfer of heat to the plastic from one end to the other via conduction this way is much more gradual and slower and generally not as fast as the other two. We're still at about 67°C in the water. And the best part about this is that because the handle is nice and far away from the action, you can hold it there quite a while without being too inconvenienced. And now, even the plastic is starting to change. So now you can see that it takes a lot longer for the plastic to convey the temperature difference between the two from one end of its length to the other. And now at the same time, because of the heat transfer is unequal, that as it cools and releases heat back to the environment, that you would expect the diamond to change color first, back to its cooler temperature. And as we shall see, this will almost certainly be the case. And we will hold this in place for our experiment a little longer while we wait for the results. So, I'm now going to clamp this in and we can watch it change at our leisure. Just testing my new conductivity diamond test. Yep, it worked already. I'm just waiting for it to cool back down so I can finish the video, and then I will consider this a good thing. over to get the ice, and the TA like holds open the ice door for me. That's really cute. And then shut it for me too. What a lovely young man. All right, let's try the ice water test. Okay, so now we have the different metals. Still not cool enough to change colors back, so in order to do the second part of the demo in an efficacious manner, we're going to add a little ice water and see if we can get them to change back to their original colors. And as you notice, quickly the diamond turns back the fastest, and it is back to its full cold color. It is much more thermally conductive than the other two. That end, you notice the plastic is still not quite back to its original color. And finishing in second place, as usual, the brass. So today we have a 4-liter beaker with some sulfur hexafluoride in it, and we're going to test its buoyancy. So as you can see, the methane gas inside this balloon is lighter than the SF6 and actually floats on the surface of it. Now this doesn't work forever because over time SF6 is absorbed into the methane balloon faster than methane and it comes back out of it. So equilibrium tends to make the balloon heavier as time goes on, eventually making it less buoyant. But for the purposes of our demonstration, methane balloon floating on SF6, it's a lovely thing. So this is today's experiment, the catalysis of hydrogen gas, palladium black. It is September of 2016. So there's a small amount of palladium black, which is palladium unactivated carbon substrate in the small container over there. I guess it's a glass beaker with a vent pipe made of glass that goes down to the bottom. So right now there's air in there, and I'm going to put in hydrogen gas. The hydrogen will be catalyzed to react with oxygen by the palladium black, and it will ignite. The energy is sufficient to ignite the hydrogen gas. So without further ado, I'm going to apply hydrogen gas to the catalyst. Ready? See? Okay. So, since it's a catalyst, the reactant is not used, and as soon as there's air to replace it, it can be done again. So once again, after the combustion reaction takes place, the hydrogen gas moves off, more air fills in, oxygen is now available for the combustion. Oxygen is now available for the combustion. And again. Now with the lights down, excuse me, I'm narrating myself.
Oh, I thought you were recording.
I am recording it. I am recording it. Yes, absolutely recording it. Ad infinitum. That works. That's more purple than our original version too.
Let's just do the barium. We'll get off the next one.
So this is lithium and barium on lithium and potassium on steel wool in a porcelain. These were soaked in a methanol with a little bit of water in it. They seem to burn on the substrate very nicely. They don't look like they're having any issues with crossover as far as the methanol fumes go, because they aren't really built quite that way. That's barium. And so barium, potassium, and lithium. Another new demonstration invented by the most prolific demo lab in the United States today. Not surprising. We are. There's no one close. Number 1 in innovation, Maynard. Yay.
Killing it.
We are. We're killing it. This is good. We took a good idea. We refined it. And just let it burn. I want to see if anything happens. I want to see if there's any jump over, if you know what I mean, from the methanol. I like that they're close together. If we did this in real life, we would have them spread out. But yeah, it looks really good. And we're on a fireproof table, pretty much. So, ready for my close-ups? Okay, close-up. Close-up. Yep.
Oh, this is only good.
So it's sort of a combination between inspired workers and innovative leadership. Yeah, I think that's what I would call it.
Wow, like imagine if you had the background behind it.
Yeah.
Now imagine if we could do like the steel wool curtain and like
Each one could be a different colored salt.
Yeah, like 4th of July, red, white,
Yeah,
and blue.
he wouldn't know what to do. He just wouldn't know what to do.
Demo
He'd just
show,
freak right out.
red, green.
So yeah, this here very well this could probably go for the show on next Thursday. So we'll get 3 or 4 of these ready. Like on Thursday morning, we'll give this a run. We'll do these 3 colors and we'll add copper.
Awesome.
Okay? I like it. Okay, I'm done. Thank you. Thank you.